Hello, everyone, and welcome to today's seminar. It is the latest in our Smart Mobility Connection series. My name is Lisa K. Schweier, and I am the Program Manager for Traffic 21 and Mobility 21. The Smart Mobility Connection series is sponsored by the Traffic 21 Institute and the Mobility 21 University Transportation Center as an opportunity for faculty to showcase their current transportation projects. It's also an opportunity for students, fellow faculty, deployment partners, and the broader community to engage and network with researchers, highlight opportunities for involvement, and foster future interdisciplinary collaboration. Please note, this session is being recorded and all participant microphones are currently muted. To ask a question, please send a message through the chat box. You will not need to wait until the end of the presentation to send your questions. Today's topic is student applications of artificial intelligence for infrastructure inspection. And our speaker is Justin Starr. Justin Starr is the Endowed Professor of Advanced Technologies at the Community College of Allegheny County, where he works to adopt and modify cutting-edge technologies for the classroom. He is also the Mechatronics Program Coordinator and teaches courses in robotics and automated systems. Before joining CCAC, Justin was the CTO of RedZone Robotics, Incorporated, a manufacturer of water and wastewater inspection robots, and he worked on several DARPA programs for I'm going to say it wrong, but it's QinetiQ, North America's Technology Solutions Group. Dr. Starr has 12 issued patents in AI, virtual reality, and augmented reality, and robotic systems, and is the author of a 2021 book on water and wastewater pipeline assessment technologies. He earned his Ph.D. and his Master's of Science in Materials Engineering from the University of Florida and his Bachelor of Science from Engineering in Engineering Science from the University of Virginia. And he has his Associates of Science in Business Management from the Community College of Allegheny County. At this point, I would like to turn the presentation over to Justin, and we're looking forward to hearing your presentation. Thank you.
Thanks, Lisa K. Geez, it's a tough introduction, guys. It's really nice to be with all of you today. And I'm excited to talk about some of the work that our students have done. So I was just talking to Joy. If y'all have any questions at any time, please just type them in. I think the view I'm going to have means I won't see them. So we'll answer them at the end, but type them in as they come up. Don't think like, oh, I want to ask this, and then you'll forget by the end of it. So let me share my screen and kick this off. Bear with me. I'm going to share some slides and then kick into full screen mode. And what I'm really excited to talk about, so if y'all have been coming to my last few talks, we've made some good progress talking about ways in which we've been engaging students with artificial intelligence. And I'll kind of talk about some of that previous work and then get into where we are today. But the theme that I've always been trying to hit is that we say AI is something that students will need to think about in the future or in 5 years or 7 years. Where really it's something that's happening today. So subtitled, The Future is Now, right? We're finding that students who graduate from community colleges, their daily work task isn't just what it was 5 or 10 years ago. Now they're being asked to collaborate or even work for AI systems. And that's just having a wild shift on how we do work in this country. So I want to kind of talk about that a little bit and talk about how cool it is. Today, I've been lucky to have students work on a capstone project using some data and getting some guidance from a company, ClearObject. So I just want to make sure I'm acknowledging them throughout the presentation. They've been great to work with. They've been very supportive, opening up algorithms, letting students see exactly how this works. So it's always nice when community colleges and companies can collaborate. It's so good for the students. So let me just lay the groundwork, right? And this is a rehash. If you've come to my previous things, you'll recognize this slide. You can even tell it's older because it doesn't quite match the formatting. But 7 years ago, right, AI is not how we thought it was today, right? 7 years ago, if you were doing AI, you were in a PhD program at CMU, or you were in Apple's Advanced Technology Research Group, right? In 2015, if you're doing AI, you're developing algorithms, you're really pushing the cutting edge, right? I think that year CMU entered a team in the World Series of Poker that was AI. Amazon released this thing you might have heard of called Alexa, like a different ball game, right? Today, where we are, though, is AI has become so democratized that everyone is using it, and we're not even aware that we're using it. So in 2022, right, you'll have AI that's becoming much more application centric. And we see things like NVIDIA Jetsons that can make facial classifiers. And in fact, last time I talked, I showed y'all how my students who were in technical apprenticeship programs, right, mechatronics, polymer technician, with just a few hours of instruction, we're able to get a face classifier up and running. So it's everywhere, it's out there. And because we have these frameworks that are built, you don't have to be a programmer to make the most of it, right? That's what we're seeing. And that's pushing the shift of AI into these businesses and into these entry-level positions where our students are interacting with it all the time. So again, this is from last time, right? So last time we looked at, could students in an introductory class make a facial classifier? Could they use AI tools and actually get something out of it? And spoiler alert, they did a great job, right? We had no expectations going into it. The students had no background in math or CS, but they were able to make an attendance taker using the teachable machine in such a way where they actually learned about labeling data sets and how many iterations to teach a neural network. Like, it was really an excellent learning process. So we kind of got some promising validation from that. And we've also seen some good success from students working with sensors of the type that we use for self-driving cars. We kind of thought, how do we take this to the next level? And the idea was, there's got to be ways in which we can use this in an application-oriented setting, right? We showed the proof of concept that students can use these tools at the community college level. We shouldn't avoid AI because we think community college students aren't ready for it. They're totally ready for it. But what does this mean, and how is this going to impact their jobs? So what we tried to do was extend this and look specifically at a few different occupations that are being disrupted by AI that we know our students like to work in, right? And really explore what that looks like by engaging our students in this process right now. So we tried to find something that was, I'm going to say, transportation adjacent. And we ended up looking at infrastructure because it turns out there's a lot of AI being applied to infrastructure right now. And students getting involved in these fields have to use it and deal with it every day. So what this kind of looks like is we found a great sample job that's been a reliable source of employment for our students. So many of our students, not many, but a couple every year, who are interested in robotics end up with jobs in the wastewater industry. And you're thinking wastewater is disgusting, sewers are nasty. Totally right? But it's an excellent place for robots. And it's a good place for students who are interested in infrastructure. And just a little background for the group, right? If you think our roads are bad, our sewers are worse, right? The tip of the iceberg. So we've got like 300 billion in imminent maintenance that we need to do in the next 5 years, 10 years, according to the ASCE. And spoiler alert, we're not doing any of it, right? So if we're thinking civil engineering, right, this is a sewer. You can see the wastewater down here. You can see the sewer up here. The lines represent exposed rebar. We shouldn't be seeing any of that. Sewers have structural elements. So when we start to see that rebar, that means there's significant corrosion happening. And it turns out in wastewater, we get this nasty stuff called hydrogen sulfide gas. It smells like rotten eggs, but more importantly, it's deadly. If you breathe it in, it turns into sulfuric acid in your lungs. And when it touches concrete, it turns into that sulfuric acid and eats it away. So we're seeing sewers being worn away at this crazy pace. And we just can't keep up with it, right? We are not spending enough to stay on top of maintenance. And in Pittsburgh alone, right, you look at what Alcosan proposed a few years ago. So Alcosan is in trouble with the EPA. There's this thing called a consent decree that basically says they need to stop discharging sewage into the rivers when it rains. So a few years ago, they put out a plan for how to deal with it. And honestly, fixing the problem, it's like we give politicians a hard time and say, well, they just don't want to do it. They want to get the votes. I would argue that it's borderline impossible in some cases, right? So Alcosan's plan that they put out to fix this involved building a parallel system of sewers that would cost about $2 billion, and the ratepayers would pay for it. So what that means is every year, if you are served by Alcosan, your sewer bill would go up 10 to 12% a year, meaning every 7 years it's going to double. So if you have a $250 sewer bill, it goes to 500, 500 goes to 1,000. It's not sustainable, right? We'd have sewer bills that are greater than mortgage payments, which is not what anyone's looking for. So as a result, in wastewater right now, if we don't address the problem, we get these giant failures, right? We get sinkholes. And Pittsburgh, we're no stranger to sinkholes, but they're happening nationwide. And people are ending up dying, right? People fall into the sinkholes, or this is one that I worked in before I went to academia in Michigan. It's like $75 million in damage. In San Antonio, Texas, a sheriff's deputy fell into, it's really bad. So we don't have to beat a dead horse, but it's not a good situation. And we're not equipped to deal with it. So what are we doing, right? We can't fix everything. So what we can do is look at it more frequently to figure out when it's going to fail. So this is the job that many of our graduates get when they leave CCAC, is they'll get jobs running these sewer inspection robots. And sewer inspection robots, by and large, are not like, autonomous vehicles. Most of them are teleoperated. So students will sit in the truck and they'll drive the robot through the sewer. In a previous career, I worked on autonomous robots. It's great because it's autonomy in one dimension. So it's a lot easier than self-driving cars. But honestly, the demand for that kind of service just isn't there. So students will get these jobs driving robots, maintaining these robots, working with folks who deal with other types of infrastructure, trying to coordinate things like capital planning. So if you're working for a city and you're in charge of roads, you don't want to come up with your repaving those until you deal with the sewers, right? Because as soon as you repave a road, you don't want someone to get down there and dig up a sewer to fix a problem. So it's very transportation adjacent in that sense. And they're good paying jobs for our students, right? Starting salaries are about $35 an hour for someone with an associate's degree. There is a lot of travel. Many of these companies are nationwide, so students travel all around, but like good family sustaining wages, and students who work in this field, graduates who work in this field, have pretty high satisfaction. So it's great because if they like robots, they get involved. If they like civil engineering, they get involved. And it's one of those things where if a student wants to feel like they're making a difference, it's a really good spot to be. So what happens though? They drive these robots through, and the robots are just, video cameras on wheels. So they're looking at problems in sewers. And right now, the job is students have to type in to classify all the problems they see. So they have to type in every time sewers are cracked. They have to type in when they're collapsed. They have to type in when there's a hole. They have to type in when there's infiltration. They have to type all of this stuff in manually. And if you're approaching this from a perspective of AI, you're thinking, well, that's certainly an area where artificial intelligence could step in and at least improve this workflow to some degree, right? So if a student didn't have to type in crack and have to type it in every time they see a crack, so a municipality can make the right rehab decision. There's a lot of typing, right? And people make a lot of mistakes. There's a great opportunity to apply some of these computer vision tools. So this is where we are, right? We have this manual process, and we're just now starting to see AI get applied. So I have a couple of videos that illustrate that. On the left is AI detecting when the sewer robot goes underwater. And you can see on the right panel, it says when it goes underwater, it's classifying that. It'll show when the robot comes out of the water. Things that a human would have to type in, now the AI is picking up by itself, right? And where that robot's going underwater, that can represent something like a sag in the pipe, where that downhill trajectory isn't maintained, and you can get backups and blockages, and important to detect. We also see the green boxes we're so familiar with normal classifiers, right? So if I play the image on the right, you'll see it's a detection that's going to pop up some roots. So it'll automatically find some of those roots as the robot drives through the pipeline. But it's actually really tough in the sense that if we're thinking about what AI can do versus human operators, right, this isn't like, oh, we found some roots, congratulations. Like, civil engineers are making comprehensive repair and rehabilitation decisions. So simply saying like green box around roots doesn't solve the problem. We need to find all the roots in the sewer. We need to do it consistently. And we need to think about why we're doing it, because if we still need the person driving the robot and AI is not as good as the person, what are we doing, right? What's the workflow advantage And we're really at an inflection point where I don't think the industry knows right now. And we see that based on how these products are marketed. So the big benefit for AI is that it can definitely multitask even the best human operator. And we'll see if it can keep up with my internet connection. But AI systems can classify multiple sewer lines at the same time, where a human operator would get bogged down trying to process everything at the same time. But AI doesn't catch everything that a human operator catches because AI doesn't have the training data, right? Some problems like roots and sewers, we've got a ton of training data. AI is pretty good at this, but things like sewer collapses, fortunately, are pretty rare. So there's just not as much training data, and the AI isn't as great at picking that up. So you can kind of ask what the real benefit is of this. But we're seeing it being deployed right now. And if you go deep in the sewer inspection space, you'll find there's a lot of companies that are making, how do I want to say this, Elon type claims, right? Full self-driving by the end of the year. You know what I mean? If you buy a Tesla, you can lease it out as a robo-taxi, no problem. Probably true someday, but not true by the end of the year, right? It's November, Elon. It's going to be a little longer. I shouldn't say that because someone will send this to him and then I'll be the subject of his tweet. But yeah, it's kind of where we are. So the AI is being sold as a tool that can replace human operators in these sewer systems. So companies are launching products saying, hey, save some money, don't hire community college graduates to do this, hire AI to do it. And then you could get an unskilled person to just drive the robot through. They don't have to type in anything and the computer can do it. But just like self-driving cars, we're seeing characteristic failures in AI. And specifically, when people don't understand the limitations of AI, we start to see them mistrust the system, right? So just like people think they can trust the self-driving car because it's called autopilot and then it slams into a truck because it thought it was an overpass, the same thing is happening in sewers. And without that education, municipalities and civil engineers are making critical mistakes right now, right? If they trust the AI system and the AI misses something and no human reviews that video and a sinkhole collapses a road and someone dies, that's significant. And in civil engineering, which is so risk averse, it's really uncharted territory, kind of fusing this cutting edge technology with such a conservative profession, right? So in here, these are good examples of ways in which humans and AIs can, come together to solve some problems. So, when we see a classic example of a failure in a sewer, ask yourself, how do I classify what's going on here? And I'm sorry, it's a lunchtime seminar and it's going to be a disgusting presentation. Like we're going to see a lot of sewer stuff. So just brace yourself. I should have said that a little bit ago. But like in here, we've got a sewer that's broken in multiple places. We've got water coming in. We've got some soil coming in. We've got, pipe. How do you classify that? And a skilled human operator is really going to need a lot of experience to do this in the right way. Same thing over here, where we have a pipe collapsing. There's a bunch of different ways you could think about that, right? On some level, to say it's a shape or a size change is not incorrect, but the context of having experience in this field means it really needs to be marked as something more significant, right? A total loss of capacity and imminent threat to blockage. If an AI doesn't pick that up, that's the kind of thing that can lead to instant property damage for someone where sewage backs up in their basement. Or what if there's a little hole, right? And the AI misses the hole or thinks it's a shadow, right? That hole is going to wear away, dirt's going to wash in. All of a sudden, we've got a sinkhole and a collapse, and things can escalate very quickly. So I'm not saying AI is not useful. I'm saying this promise that it replaces people today is a little bit short-sighted and I think misleading. So this is where we bring in our students. So this for us was a perfect opportunity to look at ways in which humans and AI could collaborate, not in some theoretical sense, but in a very real today sense, right? What are the things that AI does really well in sewer inspections? And what are the ways in which students can help the AI or work with the AI as entry-level employees? And we ended up shifting this into a capstone project with our students. So the working thesis was that a skilled operator is not going to be something AI can replace anytime soon, because they provide this valuable context, and with some training and classroom instruction, our students could play that role, right? They're not the same as 10-year veterans, but for purposes of this experiment, good enough. We also know that when people are inspecting a pipeline, there's a lot going on. And when they get to conditions of cognitive overload, this is something that's frequently reported, right? So if you think about sewer inspectors, they're inspecting sewers. You typically want to inspect sewers when flow is the lowest, so people are sleeping. So that's like 3 a.m. It could be raining, it could be freezing cold, it could be terrible weather. You're on the side of a busy interstate trying to drive this robot and label everything accurately. This cognitive fatigue is very real, especially when you see a lot going on in a pipe. If the robot gets stuck and you don't want the robot to get stuck and dig up, a road to pull the robot out, all of a sudden your attention shifts from classifying that data as accurately as possible to doing what you need to do to salvage that day's work and free the robot. When a complex failure happens and you're looking everywhere trying to classify everything, and again, you're on the side of a busy road, it's real easy to start missing data. And same thing, if there's subtle changes that you're not attuned to notice, you're just going to miss those things because that's how we are, right? If you turn up a dimmer switch in a room gradually over the course of 2 hours, we effectively boil the frog and don't know that it's even happening. Same thing, if a water level is gradually increasing in a pipe, eventually you say, holy smokes, right? The robot's underwater, but you're probably not going to pick it up the entire time the robot's driving. And there's just some of this that's a slog, right? I think when I showed that earlier slide of, what the CCTV inspection actually looks like, just take a look at some of these examples, right? So coding every single crack here, you know what I mean? And you have to go 1,000 feet of sewer. It's just going to wear you down. It's not something that's easy to do. It's just painful for humans. And again, it's an area where AI could come in and be extremely, extremely useful. So that's kind of where we were getting with these students is, can we design an experiment or a process to really look at the ways in which we can examine this? Because no one's looking at it right now. And so what we wanted to do was test at least a couple models of ways in which technicians interacted with AI to see if there were real workflow considerations that should be taken into account, or maybe the companies are right and this is people, we should stop offering this program, right? I said that kind of tongue in cheek, but that's a very real fear. We don't want to graduate students for a degree where they don't get a job or a certificate. So if AI, John Henry really couldn't keep up with the steam engine, that was something we wanted to know because we shouldn't keep offering this training. So some students ended up signing up for, in their words, the crappiest capstone project ever. And it's just a sewer joke, right? It's just all the things that they saw. But they work closely with data provided by that AI company, ClearObject, to take a look at ways in which the AI failed. The students got to try their hand at data labeling and see if they could find any insights for, trends where the AI would miss something or areas where they'd want to turn on the AI specifically, because the way it's being deployed right now is the AI is still computationally expensive. So if there'd be a benefit to applying, more detailed AI and turning on all the models at specific locations, that could be really cost effective in this case. So the students found a couple things when they watched these videos. So students watched a couple 100 hours of sewer inspection videos, and they found something that supported one of our theses going into it. And they found that operators, when they get cognitively overloaded, that's where they make mistakes. And training AI to recognize those locations and specifically compensate for common mistakes was really useful. So they saw two common things, right? So they saw in this example on the left, a robot is following another robot that's cleaning the pipe, and it's spraying this high pressure water this behind like this big concrete. So there's concrete in the invert of the sewer. You can't get it out because it's concrete. So what do you have to do? You drive the robot over this and it gets stuck, right? But the robot's getting stuck and it's going to tip over. And so the guy immediately can't type in everything he sees because he's trying to make the robot not tip over, right? So in these areas, AI could really find the things that were being missed. And it was a very consistent, repeatable observation that when someone's robot is about to tip over, they stop typing in what they see around them, and AI can salvage that, or at least identify it as some area that should be followed up upon. Same thing on the right. Use your imagination for what these debris are in the bottom of the sewer, right? But the robot's consistently getting stuck in them, stuck. And again, the operator's rocking the robot back and forth, trying to free it, and they're missing key pieces of information. So are there ways in which we could train AI or automated systems to identify these things? And the answer, honestly, is yes. And we'll get to that in a second. Other things the students found is when there's complex failures, typically a human will get maybe 80% of what's going on in the complex failure, and they'll miss the last 20%. So in this case, in this sewer, the operator found the circumferential crack going around. They found what we call ragging, but you're thinking looks like toilet paper. Absolutely. They found a tap for a residential sewer line coming in, but they missed the forest through the trees, and they forgot to type in that it was broken pipe. And we know we can kind of reliably detect this. So if we find somewhere where an operator types in 4 or 5 things, that's a good area for AI or someone else to follow up on and make sure that nothing was missed. And same thing over here on the right. I think you're getting the hang of it. So the key insight that the students came up with when they were working with ClearObject is, the AI has a couple components. It's got this vision classifier, which again, I think with some Python and some programming experience, the students could whip up a classifier that works to find things like roots, but that's really not the secret sauce. The secret is figuring out how to make this more productive. So what they found is those changes in inspection speed, when the robot's getting stuck on concrete or it's getting stuck in debris, that's the kind of stuff we want to find, right? So if we can tune the AI to the robot telemetry to try and find patterns where the robot seems to stall and we notice the operator is not coding as much, that's a really useful region to flag either for follow-up by a human working in the office or a data reviewer, or even an AI system that might find things that the human missed. So based on what we saw before, the students worked with ClearObject to train this model that would detect from the robot telemetry areas where it's moving through the pipe at 30 feet per minute, the operator's coding everything, and then all of a sudden it starts to slow down and stop. And this is an area where classically we would expect to see the operator miss things, because as the robot's slowing down, there's some reason it's stuck. What's the purpose? Cognitive overload is happening. So can we put that decision support in? And the answer was absolutely, right? So the students found this without even looking at the video, right? They didn't even see what it was. And then when they went to the video, we totally found it, right? So robot going through the pipeline, there's this big grease in the crown of the pipe. And grease is exactly what it sounds like. It could be from a restaurant, grease trap. But you read news articles about the Fatberg in the London Museum. That's what it is. It sticks to pipes. It's impossible to get rid of. If you find something that can dissolve grease in sewers without killing the planet, like you'll be literally a billionaire. I'm not even joking. But what's happening is the guy inspecting the pipe is coming up on this grease. He doesn't want to smash the robot through the grease because then it'll smear his camera and he won't be able to see anything else. So instead of coding and classifying everything he sees, he slows down and he adjusts the robot and he works carefully to get the robot under the grease so he can finish his pipeline inspection and continue on. But all of this critical information about the grease ends up getting missed because the guy is so focused on driving the robot. So what the students found is that using AI to identify this system for further analysis and further turning on the right classifiers could find these defects automatically so that it's not a question of haranguing the inspector for what they missed. It's compensating for a human shortcoming and applying that AI as a decision support tool, not something that's going to replace the guy, right? The guy did a great job all the way up until this point. And here, arguably, he missed, 3 little defects or 3 little codes. But just like they say in aviation, they don't remember you for all the planes you didn't crash, right? So this guy would get chewed out because he missed something pretty significant. Same thing here, right? We see another example of an area where AI can be deployed. I mentioned those subtle changes that people are just bad at noticing, right? Water level in a pipe changes all the time, and it's unreasonable for me to tell the robot driver to write every time the water level changes, right? You never get anything done. Water changing all the time. People flush the toilet, water changes. Disgusting, right? Remember that. Never lose sight of the fact that it's disgusting. But we had something interesting happen here, right? So the students saw that this is kind of weird, right? There's an AI model where water level starts out low, water level goes way up, and then water level comes right back down. And that's a classic indicator that there could be a sag in the pipeline, right? Because the robot's driving, the water level doesn't actually increase, but the pipe goes down below the plane it was existing in previously. So it fills up and the robot temporarily submerged and comes out the other side. That's critical inspection data for something like a hydraulic model and building out a hydraulic model. And this is exactly what we see in the video, right? We see a very low water level. We see the water level temporarily rise and then come back low again. And it's something the robot driver would never notice because they're busy driving the robot. They're coding all of those cracks. They're finding all the routes. This is something that just happened, and they kept driving the robot so it didn't get stuck. But it was an excellent use case to deploy AI, again, as a decision support tool. So when we look at the future of the workforce, right, these guys making $35 an hour have a ton of opportunities. So if you're an owner of an inspection company, what do? Do you yell at this guy for missing all these things and he'll go get another job from somewhere else? Or do you use AI to pick up for those things that honestly it's unreasonable to ask him to do anyway and make his work product better, right? It's sort of another important thing.
And Justin,
yeah.
Sorry, we did have a question come in. Can I stop you here?
Yeah, please.
Okay, so the question is, when reviewing problem areas, for example, places where the robot slowed down or almost tipped over after the fact, do you have any information to indicate whether a human employee or AI would do a better job?
Good question. So honestly, this is the trick. So click. It's about to get there. Here. So honestly, the AI right now, it's okay, but it overcodes everything. So it's too many false positives right now. So the AI misses things in that it sees something where there is nothing all the time. So right now, the AI is very useful at identifying those regions for follow-up. The AI is useful at making a triage or a first pass to identify what could be there. But ultimately, at this stage in the game, a human reviewing the predictions of the AI in those areas is what I would recommend, right? If I was going to a civil engineering firm and saying, hey, here's how you prevent a sinkhole from happening, use AI to find all these spots that someone should follow up on. Otherwise, literally, here's the state of the art today. Otherwise, an inspector at an engineering firm has to watch all of those sewer videos, hundreds of hours of them, to find mistakes or things that someone might have missed, right? Could you imagine that? You think your job as an EIT was terrible. Your job is to watch sewer videos 8 hours a day, 5 days a week for months until a project. It's just disgusting, right? So that's what we do right now. So deploying the AI to find the areas where some follow-up or investigation is extremely effective. Using AI to figure out what went on in all those areas, not the right tool for the job right now. Soon, give it time. I think as more folks start specializing in this space, it's only a matter of time. It's just not the time right now, right? It's just, I sit here, the failure rate in excess of 80%. That's just, we saw, that's not a good quantitative number. That's just anecdotes. The students are not trained inspectors, but when the students went through, they said, wow, the AI really found too much in areas where there wasn't a lot. Like you go here, where the robot's getting stuck, and there's just a couple of things, you know what I mean? There's, some concrete, but the AI gets confused, and are these offset joints? It will get there, but today it's not. And I think that's a really important point, that there's ways to leverage this AI and deploy it responsibly with partners who are interested in AI, right? If you think about self-driving cars, let me just use that example, right? It's great when you deploy it for a portion of your workflow. Like if you're in stop and go traffic, adaptive cruise can be great. If you're on a mapped highway, GM Super Cruise, fantastic. You know what I mean? But if you want to say, I'm at work and I want to say, car, drive me home, it can't do it. Like it reliably can't do that right now. And if you think it can, let me just push back and say, would you do it with your kids in the back seat and you're not in the driver's seat? Absolutely not. No one's going to do that today. We've all been in Teslas that do the unprotected left or the phantom braking. It's just not there. The same is true here. It's not ready to replace the human, but wow, can it help support and fix mistakes that humans make commonly? It can also go beyond the human, right? So we have some cases where the human might notice the water level increases, but AI can analyze the pattern of the water level increase and come up with a hypothesis for why, right? When we see a water level increase like this in a sewer line, what we're actually seeing is a bunch of debris below the flow that's causing a loss in capacity. Human might not know that, and human actually right now is trained not to say that because humans aren't supposed to guess at what's going on below the surface because people guess all kinds of things, right? They guess possum, they guess alligator, all over the place. But AI can reliably say, wow, this pattern looks like debris. I can recommend to the municipality who owns the sewer, they should schedule this for cleaning, right? That's sort of how it works today. And it makes that decision support. So would I say you should clean everything the AI recommends? No, but I'd say take what the AI spits out, give that to your engineering firm or your township engineer, right? And have them go through the AI's recommendations and get a much more targeted, focused plan rather than just reviewing hundreds of hours of sewer videos, right? Hundreds of hours of sewer videos is ridiculous. And that's what happens right now. The students also saw, right, where there's these cracks, right? Not only could the AI find the cracks and trace the cracks better than a human, but it could tell when those cracks opened up and closed and really quantify what was going on. And when engineers make their models for the likelihood of failure and the consequence of failure, that's much better data than any human estimating, right? So a human might say crack, crack, you know what I mean? But the AI can say, actually, it's opening up. It started as 1 millimeter, now it's 3 millimeters, and it's getting worse, and it closes up again. That's the difference between replacing an entire sewer line and repairing just a small section of it, right? So AI can add that value. It can make those size measurements. It's just a really useful tool. The other thing that we came up with the students, and this is both amazing and depressing, right? It's amazing because it's such a thing that should be done. It's depressing because no student gets the reference on the slide, right? You say trust but verify. We're all thinking Reagan. They're like, who's Reagan? You know what I mean? So it's just evidence we're getting old. But a consequence that we saw by having the students work with ClearObject is, everyone's kind of thinking about this workflow. There's a real need to log, in a civil engineering sense, the audit trail between an AI making a decision, an engineer making a decision, and a sewer inspector making a decision. And this is one of the key, I don't want to say student originated recommendations because it happened as part of a dialogue with ClearObject, and they were so kind donating engineer time to work with the students. But like the result of that conversation is a product feature that there should be an audit trail in this, that every time the AI finds something or doesn't find something, other products that are being sold right now, you can correct that, right? You can say, well, the AI was wrong, let me fix it. But no one is logging that and storing it and using it to improve the AI or see the history of an inspection. So this audit trail works in a couple ways, right? When the AI begins to get better than people, we can use it to help people fix their mistakes. But for now, when we're constantly correcting the AI, it's really useful to see areas where we all agree, the human and the AI, and areas where the human and the AI disagree, and some kind of corrective action was needed. So this is a good example, right? This is a really hard thing to pick up on. It's not a hole in the pipe or a void is someone's residential sewer connection, but instead of having a factory installed connection, someone with a hammer just broke it in, right? So we call it a tap break-in, hammer intruding. And this was one of the cases where the AI, the original inspector, and the engineer all agreed that this was what was going on. That data point is super useful from a labeling perspective. So when companies go to retrain their models, having that feedback maybe distributed from everyone who's using a product to say, hey, we actually agreed with the AI in this case, can help them improve much faster than they'd be doing otherwise by suggesting this AI is a standalone product that's not going to continue improving, right? It's just not ready today. And that's, I don't know, I would defend that position pretty strongly. So last time, right, we said AI should be a general education goal. And I think there was some skepticism saying, well, it's not really here. It's not something that'll impact students. I said controversially that students are going to end up working with or for AI in the next couple of years. And what we saw with this capstone is it's really true. And it's here in a way that's faster than we predicted. And if we don't get our students ready, they're just getting thrown into it, right? And AI is displacing them and supplementing them. And imagine they're working as an operator of a sewer robot, and someone says, hey, we got this AI, you're going to use it on your job. If the student doesn't have any training, they'll respond with fear. They'll be afraid of that AI. They might blindly trust that AI, where really the relationship is much more nuanced. And we can do a lot to, one, help students get prepared for that as they enter the workforce, but two, help companies who are willing to work with us and acknowledge that AI is changing to really use students to drive what that collaboration looks like. So, what we walked away with, and I think the students ended the engagement excited about AI, but they really, when they're using these terms, community college students are saying it's a great decision support platform. We've done our job, right? It's been demystified. They know this is a complex system that they can interact with, but they're not viewing it like Tesla autopilot. They don't think it'll drive them home. They know there's some levers that they can pull to adjust the process, and they understand there's going to be feedback going both ways with the system. We also see, and this is a recommendation that, I mentioned at a sewer conference where I was sharing not the same thing, but something based on this Capstone experience, that when we say AI is going to replace human operators, people are just being disingenuous, right? That's not going to happen. AI right now is making more mistakes than humans, but it's making them in a predictable way, right? So the right answer is teaming AI and people up right now. That's a harder message to sell, right? You could save 30K a year or 80K a year by replacing people is an easy sales pitch, but the nuance that you can get, results that are 95% more accurate by having AI work with the people. What's the ROI? How do you quantify it? I don't know. That's why I do professoring, not marketing, but it's more honest for sure. And then it's cool that the patterns our students saw are now being integrated into this commercially available tool. So I think you can give them this education at the 2-year college level, and they're not programmers, right? They're not going to develop AI systems, but their findings were used by developers and product owners to actually be something that's in shipping product. And for students, that's super cool, right? Their work is out there being used in industry today. It's fantastic. So it's just one capstone project. I don't want to make more of it than it is, but I think it cements where we're going, right? We've been saying AI is a skilled trade. It started out as just kind of words that sounded hyperbolic, but the more we work with it, the more we really believe it. And this example just showed us that the future of work is changing, and it's never too early to integrate that into what we're doing with community college students. So yeah, I don't know. I guess there's more failures that I thought I'd scare everyone with, but that's all I wanted to say, right? The big thing is it's exciting. We love working with companies. We owe ClearObject a big thank you for sharing the data, making technical resources available, and working with the students. It was just a great experience for all of us. So if there's questions or comments, man, I'd love to answer them. But otherwise, thank you all so much for your time. It's always great to share this work.
Justin, I always really appreciate your conversations and the information that you're sharing. We do have a couple questions, but before we get to those, I did also want to thank you for kind of closing the loop as to why this is related to transportation. And that, if the sewers fail and the roads fall down, that's kind of a problem for transportation. So let me read you, we have a couple questions, so I'll start with the first one. When reviewing the problem areas where the robots slowed down or almost, I just read that one. So will AI always require specific and extensive training for each use case to reduce errors, for example, false positives?
So it's a good question, and I don't know. So I'll be upfront about that. I think there's ways you can sneak it in there. So I think if I was in this space right now, what I would be doing is I would be deploying a training system in these tools that human operators are using, and I would just be logging everything that they would do, right? And I would send that back to my system, and then I would be getting this database of trained data from maybe hundreds or thousands of users. So is there a chance that someday we get this magical unstructured learning? Sure, but like just the nuance between telling the difference between a crack and a root. And this isn't Tesla vision. This is NTSC 640 by 480 interlaced, right? A crack in a root in a sewer where there's a lot going on and it's interlaced analog video. Man, that's tough, right? Without a lot of context. And it gets into not only frame by frame predictions, but there's almost a temporal aspect because you can move around and see that the root has some depth, whereas the crack is flat. Man, it's tough. So I can't imagine where you have no labeled training data that you use for these systems. But, anytime I say I can't imagine that, someone's working on it. But I think for the foreseeable future, there's going to be a ton of training involved. And I think whoever has the most data in this space is going to really, accelerate by leaps and bounds.
Thank you. Next question. How cost effective is AI in this particular use case? How does AI compare with the cost of other tools that employees might need? And is it even possible to roughly quantify the potential savings of using AI over time?
Yeah, so I think so. And so there's a couple of things. So one is this sinkhole here, right? 75 million. Look at this caption, right? Blamed on human error from sewer workers. So if the AI finds the problem, geez, what could you charge where it doesn't pay for itself, right? We're seeing these tools that are subscription services, a couple $1,000s a month, less than a salary for an FTE. And it's driven by cloud computing costs. So as the cost of cloud goes down, AI becomes more affordable. I think you can really make a good case for ROI, improving data quality. What you see in municipalities, and I'm not here to hate on municipalities, but they really oftentimes got involved with doing these comprehensive sewer inspections because of things like Alcosan's consent decree, right? Where Alcosan has this problem and the EPA stepped in and is saying you have to fix it. So you get municipalities that may be inspecting all of their sewers, but they have a backlog of months of inspection data. So how do you quantify the value of going through months of inspection data and actually finding and acting on problems that wouldn't be addressed for years, right? The rule of thumb that I use is there's this, I forget where I read it, but it's the rule of fives. And that is every time you make a decision to defer maintenance, the cost goes up by 5x. So if you are acting on things you find in sewer inspection videos and you can fix them for $1,000, the alternative, if you can't find that problem again for a couple years, it'll have gotten so much worse that now it's $5,000. And if you're digging up and replacing the sewer line, it's $25,000. And that rule of thumb is held up pretty well. So clearing out this backlog of inspection data and getting some actionable insights, it's something that I think there's a lot of work to do to quantify and show that value. But if you imagine fixing a problem by sending a little thing down to inject some grout versus digging up a road, fixing the sewer, repaving the road in terms of time, residential disruption, there's so much work to do here to more formally understand this.
Okay. There's a lot of questions, Justin. This is awesome. So before I get to the next question, I do want to pass along a comment that somebody said they thought this is a cool course and they're pleased to hear that folks out there are working on this with students. So yay.
Right.
And then the next question is, could you identify some other jobs where AI could be a very useful tool for employees?
Yeah, so we found one. The other one we've been looking at, and not the subject of this because it's even less transportation adjacent than sewers, is HVAC. Man, there's a lot of work in data analytics and looking at the performance of HVAC systems and using AI to do not just PM schedules, but predictive maintenance, and having students understand those AI systems to know when to go service something and know when something is a signal buried in a lot of noise like vibrational data. We're seeing a huge interest in that at the community college level, so much so that Train, the maker of HVAC systems, is sponsoring development of data analytics courses. So that's one area. Those are just two I can think of off the top of my head. Not limited to that, just limited by my thinking at spur of the moment.
No, that's fascinating, actually. And Nick Martinello is on the call with us as well, and he would like to ask a question.
Sure. Thanks, CCAC. Justin, this is a super cool talk, and it seems like a really awesome course. I agree in many ways with your assessment that we need to be teaching students to be working with AI, to be learning about them. You showed some example here that, one is about, say, like robot piloting, driving robots, monitoring robots. Another one is about computer vision, understanding, what an AI can see. Can you speak a little bit to some of the other, like, what are those core fundamental skills or core fundamental like AI technologies that you think students need to learn about so that when they go out to these roles, they're prepared, but also if they, if they go to other roles, it's like, oh, I've seen other AIs, because you're never going to work with all of them. So I'm curious about your thoughts there.
Okay, so yeah, so this is something that we have spent a lot of time on, and we have some fuzzy answers. So like the core principles are, one, like systems level thinking. So understanding what sensors are, understanding this link between inputs and outputs, and understanding what happens when you begin to give systems data that they weren't expecting. So some things that we do with students right now in our autonomous vehicle lab that's really effective is have them play with a LiDAR unit, get used to a LiDAR unit, and then all of a sudden spray a bunch of water on it, right? And looking at how that signal degrades is not the way that students expect, right? Because they think, well, I know what happens to my eyes when I'm looking through mist. The LiDAR does not behave that way, and it really throws the students for a loop. So the more they can understand what input data looks like, how systems handle that data, and what those common failure modes are, I think that's huge. The other thing that's critical is just understanding that machine learning, right, most AI that students are going to deal with is based on machine learning. So understanding the fundamentals of machine learning, that it's based on labeled data sets right now and problems that can be introduced when training systems on data sets. We can give students projects with computer vision where we can give them a bunch of bad training data and they can watch the classifier make results that we all expect, but they don't see it coming, right? They have no idea that this is about to happen, and they'll be using products that are not well thought through, or they'll be using in things that are edge cases, and it'll be giving them predictions that they don't understand. I think this is key. So if I'm kind of summing it up, it's a working knowledge of how AI makes these decisions, right? That it relies on a lot of incoming data, whether that's sensor data, whether that's labeled training data, and then really understanding the failure modes of when it goes wrong. Because I think our students will have no trouble trusting AI, but when the AI begins to do something that they don't expect it to do, they need their value as humans is adapting to that in the right way and knowing what to do and how to handle those situations. And we can give them a lot of familiarity right now. I hope that answered your question.
That does. That's super cool. Very cool. Thank you so much.
You bet.
Okay, last call. Does anybody have any other questions they would like to ask? Well, I'd like to say this has been really fascinating, Justin. Every presentation you do, I learn a little bit more about AI. As somebody who didn't grow up with a lot of AI, it's helpful to kind of get it in pieces and it builds upon itself. So thank you for doing that. We appreciate everybody who was here today. We know there are other people who are very interested in this topic who are going to be watching the video online. So you will see in the next couple days a post on our What's Happening page that talks a little bit about the seminar as well as a link to the video. You'll also be getting an email from us asking you to take a short survey about the session. For students who are on the line who are interested in engaging in transportation topics, Carnegie Mellon University has a transportation club and would love to be able to have you join them and get involved in their activities. Our next Smart Mobility Connection will be in early December, and you will be getting an invite to that shortly. So thank you all for being here today. And if you have any other questions, feel free to contact us and just reply to the email you got this morning. Thank you so much.